So I just finished the implementation of simple platforms demo, and it looks like give me a second, clear. It looks like this. So it basically the most primitive 2D game. It's not even a game. You don't have winning or losing condition here. But as you can see, I implemented basic collisions here. I implemented basic camera following. I implemented basic collisions with the ceiling of the platforms. I've implemented the sticking to the platform. As you can see, I don't touch the keyboard, and player just it just continues moving towards the platform's direction. You can hit the platform from below. You can hit the platform from above, and everything behaves as expected. Yeah, and now I already implemented this. I'm recording this after I implemented the stuff, and basically the implementation is from scratch using raylib library for all this OpenGL stuff, and just C for basic business logic of the game. Yeah. So let's begin. So let's implement platforms in raylib and C++, or maybe actually maybe in C. First of all, let me show a little bit of example. Some time ago I did a simple game. Let me find it. No dungeon, no dragons. I hope it will build. Let me grab it. Git clone here. Do I have makefile? Yes, I do. Simple makefile. Nice. Yeah, okay. Make directory build Linux make. Okay. Build Linux game. Can you see this? Yeah. So basically it's a simple platformer game, and I implemented platforms here. So platform is just a rectangular collider or obstacle, but it's a little bit different from the static obstacle, because when you are on the platform, you basically moving with this platform. So for example, in this case, when you have a platform which is moving horizontally, you basically move towards the direction of this platform with the same step as platform does. And you need to handle this case kind of separately from the general collision detection and collision resolution logic, because if you handle like all collisions, you will slide on top of this platform. You will basically stay on the same place, and the platform will move, and you will just drop from the platform. It will be like so. Let me show it. Yeah, I cannot show. Anyway, you got the idea. Man, it was a great game, but I didn't finish it, as always. Yeah, so and if you check the actual code, it's just a single file with 2000 lines, and honestly I don't want to review this stuff. I just want to implement the simplest case, basically when you have some platform moving horizontally or vertically, and you just want to be able to stay on this platform and not fall from this platform. Okay, let me remove this. Let me create new directory, platforms, and let me download the raylib. Oh my god. Raylib GitHub. I'll just take the latest zip archive. Am I recording? Yes. What do I want? Git clone. Not clone. Get here. While it's downloading, I will create a source directory. I will create include directory, and I will create a lib directory. Also, I will create compile flags.txt. It's just for Vim to understand the locations of header files. Probably you don't need this compile flags file. Also, I need clang format file. Probably you also don't need this file. It's just formatting options for clang formatter. That's it. Okay, raylib is downloaded. Let me unzip it. Master. Raylib master source directory make. While it's making, I will copy all necessary header files into my include directory. Raylib master src. What do I need? I need raylib.h here. I need rlgrl.h here. I need rcamera.h here, and what else? Raymas. Yeah, 4 files. Okay, the library successfully built. I can put it in library directory. Copy raylib master src lib raylib here. Yeah, and let me remove raylib master source code. All right. What do we need? Let me create the basic main.c file, or maybe cpp. Yeah. Actually, no. Let's do it in C. I just thinking about that we will need some vectors and we will want to remove entities from vectors, and basically maybe it's easier to do in C++. Anyway, int main void. Let me include raylib. Yeah, now Vim can find raylib.h file in the include directory, because I added compile flags to my project. So if you're using Vim, you can use compile flags for Vim to understand where the header files are located. Let me init window, screen width, screen height, and name platforms. Let me define the stuff. Define screen width 1024 and screen height 1024. Okay. Let me set target FPS 60 and let me enable anti-aliasing flag. How do I enable this? Set no, config, set config flags, yes, msa hint, and the basic main loop, while loop, while window should not be closed, I begin drawing, and drawing right away, begin mod 2D camera and mod 2D. Also I want to clear the screen, clear background with some background color, static const color, background color, let's say something like 2020-2020-255, and camera, static camera 2D is equal to camera is equal to, what do I need here, is equal to this stuff. Offset is just the offset is just half of the screen, 0.5 times screen width, 0.5 times screen height. Do I need F here? No, probably not. Target is just the middle of the screen. Well, not the middle of the screen, since we are working in the camera space. Camera space. How should I say? Camera space. Since we are working in camera space, not in the screen space, target is not the middle of the screen. It's basically the middle of the coordinate space. So we basically say that target is just 0, 0, center of our coordinate space. And rotation is 0. We don't need the rotation. Zoom, let's say 50. Clear background, begin mod 2D, and let's draw a circle V. This function without V is basically drawing circle by X and Y coordinates, and draw circle V is drawing circle by just coordinate of the center. And honestly, this function without V is not usable, because as you can see, it accepts integer values, and if you pass real, not screen space pixel coordinates, but real camera space coordinates, you probably want to pass floats and not integers, so you probably want to use draw circle V. And center, let's say vector 2, 0, so it's beginning of coordinate space. I need to include this not this stuff. I need to include ray mass. Radius, let's say 1, and color, let's say red. Let me try to compile the stuff. GCC output here. Platform. I want to build everything in the src directory, all files with extension .c. I need to include this directory where the headers are located, and also I need to set libraries directory lib. I need to link against the raylib, raylib. What else do I need? I need to link against lp thread and lmass and ldl. Yes. If you are compiling the stuff on, for instance, Windows, I suppose you should use another flags, but I never compile stuff on Windows, so. But I suppose it's simple in the same way. Okay, it's compiled. Let me create basic make file, and I'll just create a single target here. GCC output here, source files here, include directories and lib directory and linked libraries, and also let me add warnings all flag. Let me open another tab, src tutorials, platforms, make and run platform. Yes, great. So it's just a basic setup for raylib project. Now let me implement, I don't know, maybe some sort of a player or entity that we will move in the world. Let me call this stuff type def struct player. What does the player need? What does it need? It needs definitely it needs vector to position. Yeah, maybe let me think. Let's create just the position. Let me also factor out this stuff a little bit. Load function, load, this will be a draw function and unload function. Draw, wait, draw and unload. Do I need unload? Yeah, at least I want to load. At least I want to close the window. And in the create function I also will create player. Let me leave small comments. Initialize raylib window. Well, it's formally not a raylib window. I suppose it's a glfw window, but we're using raylib as the kind of proxy for all underlying OpenGL and low-level stuff. So initialize raylib window, and here player. Let the player be global static variable, static player, and it's just 0 from the beginning. And now I will initialize the player position. Let's say center of coordinate space vector 2 0, vector 2 0. Let me create function draw player. I will accept player by the pointer player, and I will simply draw a circle for the beginning, but later we will change it to be, I don't know, maybe rectangle. Draw, but maybe I don't know. Draw circle. Sorry. Draw circle V. Player position radius 1 color red. Okay. Draw player. Let me draw player here. Draw player. And I need to pass player by the pointer player. Well, of course, I actually don't need I don't need the pointer here, because I can simply use the global variable. But I prefer to keep it like something in the middle between well, I don't want to say object-oriented approach when you pass the object by the pointer, like self in Python or like this in C++. But I also don't like this OP stuff in terms of inheritance and whatnot and patterns. I just don't like this, and that's why I prefer something in the middle. I usually use functions, but I pass object which I operate on by pointer. Okay, draw player. So let me run this stuff. Okay, and now this is not a circle, it's our player. Let's maybe change the color, like green. Yes. Yeah. Okay, now let's implement basic movement. Just basic movement. Draw. Let me create update function. Draw player void update void. Let me update player player void. What do we need for player updating? Let me well, first of all float delta time, get frame time. Let's say that, let me think. Let's handle the VSAD buttons for movement. So basically, if is key down, key V. Let me create vector to direction vector to 0 from the beginning, and if we are pressing the W button, we basically change the movement direction to be Y plus equal, not plus, the upside is a negative Y, so we basically minus equal 1. If key down S, this will be plus. If key down A, this will be X minus 1, and D X plus 1. Now I want to normalize vector to normalize the direction, because I want the direction to be the unit vector, but in general it can be not the unit, because if I press, for instance, D and W, so right and up, the direction will be 1 1, so X component will be 1 and Y component also will be 1, and the length of 1 1 is basically square root of 2, and but I want the unit direction, and I just normalize it. And after that I want to apply this step to the player position. So I basically say that vector to step is equal to vector to scale. I take the direction and I just scale it with what? With player speed. Player speed. And let me create new member, float member, player speed. Player speed, let's say I don't know, 5 player speed step, and now we have this step. It's basically, it's pointing towards the direction, and direction is defined by the pressed buttons, and the length of the step is just basically player speed, and I want to apply the step to the player position. Player position is equal to vector to add player position step. Let me run. Oh, yeah. Of course, I forgot to multiply it by dt, because speed has basically measurement units meters per second, and step has measurement units just meters. So I cannot assign meters per second to meters. I only can assign, well, I mean in from the physical point of view, I can only assign the same measurement units to the same measurement units. So if I want to assign meters, if I want to assign something to meters, I need to convert this something to meters. So I need to multiply by dt. Yeah, and as you can see, if I move by the diagonal, so basically when x and y components are equal to 1, my speed is the same, because I multiply my speed by the unit vector, by the unit direction. So I'm not cheating when I'm moving diagonally. For example, you can see that if I don't normalize this stuff, the diagonal movement will be faster. As you can see, it's faster than vertical or horizontal movement, and it's not correct. We need to normalize the direction. Okay, but if you want to implement platforms, I suppose we don't want to play the top-down game. Usually we implement platforms in side-scrolling games or platformers games and whatnot, and that's why I'm thinking about maybe we don't need the vertical movement like VS. We don't need this. Maybe we should move only horizontally. Yes, but now, as you can see, we don't have any ground. We don't even have the gravity force. Let me introduce the gravity force. I need to make a small break to smoke a cigarette. So, where was I? We were here. We updated player position. Let me I a little bit forgot what we were doing. Yeah, updating position. Okay, let's maybe apply some gravity to the player, because now, as you can see, we're just moving horizontally. We even cannot move vertically, because now we are playing side-scroller game, not the top-down game. Yeah, and we don't have any ground, any platforms yet, and we don't even have the gravity force. Let's apply gravity to the player. Let's say define gravity. Gravity what? Gravity, not force, but gravity acceleration. Let's say, I don't know, let's say 1 for now. Gravity acceleration. And when we updating player, when we let me just apply gravity to the player itself. Well, actually we need to introduce vector to what do we need? Velocity, yes. And when we initializing player, we say that velocity is basically 0. And we want to update this velocity. Apply gravity, and here keyboard inputs gravity, update position, gravity, player velocity. Gravity, we measure the gravity in, let's say, meters per second acceleration it's square, meters per second square, meters per second per second. So it's basically rate of change of the velocity. So let's change the velocity by this rate. Velocity, let's say vector to velocity step. So basically change of the velocity step. Vector to scale, velocity step. Well, actually gravity is pointing towards the negative y-axis, and it has 0x component, so we can simply say that velocity step is float, it's y velocity step. Maybe velocity y step, or maybe velocity step y. Vector to scale, gravity, acceleration, delta time. Yes, so we it's not a vector, it's just scalar value. Yeah. And we say that velocity y, we apply this velocity step. Well, let me just do it like this. Player velocity. And when we updating the position, so let's say that the keyboard inputs, they just apply immediate position change. So when we pressing keyboard buttons, we immediately change the player position. Well, not immediately, but I mean in this specific frame. Well, let's say immediately change the player position. But also player has some kind of velocity, which also is intended to change the player position. So let's change the player position by direct keyboard input. Let's say that this is position step, keyboard inputs, and now also let's apply give me a second, player position. For some reason I removed this piece of code, position step. And now let's apply velocity. Let's say that another position step is equal to vector to scale. Let me take the player velocity and multiply it by delta time. Yes, so if we factor out time from the velocity, we basically obtain position step, and we can player position is equal to vector 2. Well, let me do the following. Position step is equal to vector 2 at position step, like so. Velocity, keyboard inputs, apply position step, and now we want to apply final position step. We add previous player position and position. What the what? Position step. That's it. Now what should we see if I run the program? We should see that this circle begins, basically it begins to fall down. Yeah, and as you can see, it's falling down, and it's in fact accelerating. But maybe I want to decrease zoom a little bit, maybe 20, and increase gravity acceleration like 10. Maybe it's too small, too little, too small. How should I say that? Gravity acceleration. 30. Maybe 50. Yeah, maybe 50. Okay. Somebody is writing. Sorry. Let me implement now maybe basic ground, because now, as you can see, player is just simply falling down to the very hell, let's say. I need to well, first of all, let me make the player not round, but maybe rectangular. Vector, let's say vector 2 size. Velocity, vector 2 size. Let's say 1. Maybe not 1, maybe 0.5 by x component, and 2, maybe 0.8 by x component, and 2 by y component. What do you need? Yeah, it's C. You need explicitly put vector 2 here, size, and now when I'm drawing the player, and also let's say that the player position, it's basically the bottom middle point of the rectangular. Yes. So when we drawing the player, draw player. Let's say draw rectangle, let's say rect here, and color orange, and rectangle is, what do I need? Width is equal to player size x, height is equal to player size y, x is equal to player position x plus 0.5 times player size x. Yes, because by default not by default, but by design, I should say. By design, the raylib rectangle is x and y coordinates of the raylib rectangle are pointing to the top left corner. So we want to offset the x position by the half of the player size, and we want to offset the y position y plus by the whole player size, because top left corner needs to be translated to the bottom size. So we want to offset to the whole size y, like so. And maybe let me factor out this into a function. We will need this later, I suppose. Rectangle get player rect player, and I will return this stuff. Return rectangle like so. Yeah. Rectangle rect is equal to player get player rect, and I am passing player here. Player. Okay, let me draw. Okay, maybe a little bit wider. Let me set. Where was it? Here. Maybe one. Yeah, it's okay. All right. Let me now draw the ground. Let me create static array. Let me create static array with obstacles. This is my player. A little bit of beautification. 75 dashes. 75. This is player. This is camera. This is player, blah blah blah. Globals. Game. Functions. Game. Functions. I don't know. Game. Globals. Static. Obstacle. Well, let's just put rectangles in this vector, not vector, array, rectangle, obstacles. By the way, am I recording? Yes. Obstacles, rectangle, obstacles, max n obstacles. And max n obstacles will be, for example, 16. Doesn't matter. And also static int and obstacles. Yeah, and since we are coding this in C, and that's why I was thinking about to code this in C++, because now I need to manage all this manual array stuff. Like I need to track number of obstacles in this array. I need to allocate static array, and I don't want to deal with dynamically allocated stuff in this project. So basically I will allocate just empty statically sized array, and I will create player. Well, let's maybe even create the structure, obstacle structure. Well, no, I don't want to do this. Oh no, yes, I don't want. Yeah, and in order to spawn the obstacle, let me create function void create, or maybe better spawn. Yes, because actually they are already created in this static array. They just all zeros, and I want to spawn this. So I want to fill this the specific empty slot in this array with some meaningful values. Spawn obstacle. If n do I really? Well, I suppose yes. Where should I put this? Globals. I don't know. Let me put player here. Let me put player here. Let me put obstacles here. Let me put obstacles here. And and obstacles. If n obstacles is equal to max n obstacles, it means that I can't spawn any obstacles. No more obstacles in this case. Let me just return for now. Let me now take the pointer to the free obstacle, to the free rectangle. So basically obstacles and obstacles. I increment number of obstacles, post increment, and I get the rectangle obstacle is equal to, this is pointer, obstacle spawn obstacle rectangle rect obstacle is equal to rect. And let me return this index just in case. Return idx. Otherwise return -1, like so. Spawn obstacle. Let me what? Void draw obstacle. I just don't like. Maybe I should factor out. Well, fuck this. Draw draw rectangle rect color obstacle player is orange. Well, let maybe obstacle color. Obstacle color, and obstacle color, let's say 60, 60, 60. And now let's spawn some obstacles. maybe one obstacle, player obstacles, spawn obstacle, rectangle, let's say x is equal to top left corner, yes, minus, for instance, 10, y is equal to let's say 10, width is equal to minus 10, 20, and height is equal to 5, for example. Okay. I didn't draw. What am I trying to see here? Draw player, draw obstacles. Draw player. Maybe I should draw obstacle. Yeah, maybe let's iterate. Here I want to maybe iterate for int I is equal to 0, I less than n obstacles plus y, and I just draw I take the obstacle, rectangle, rect is equal to obstacles I, like so. Maybe like so. Yes, maybe I want to make this a little bit thinner. Maybe yeah, let's make it maybe 2.5 minus 20, and it's 40. And a little bit brighter, like 100. Maybe even 70 RG and blue 0. No. $80-20. What am I doing? Why? Last try. It's enough. Okay, now I want to implement maybe some collisions, because as you can see, it's definitely not playable. Maybe also let's implement quickly reset button. Update reset. Void update reset void if is key pressed, key what, key R, if key pressed. What do I want to do if key pressed? What and what? Add game. But here we set player, but also we want to, when we loading the game, we want to clear the obstacles, just setting n obstacles is equal to 0. We don't need to clear this array anyhow. We don't need to zero it. We just want to set number of obstacles equal to 0. That's it. This will be enough. Load game. And if I press key R, I just simply load game. That's it. That's why if you have static arrays in your program, it's very simple to reset the state of the program or to dump the state of the program on disk, like for example in save file. It's very useful. Well, and the downside is that you need to manually track the number of objects in your arrays. You manually need to handle the memory of this arrays and whatnot. Let me check that I didn't break anything. Yeah. Let me implement collisions. I'm planning to use only AABB collisions in this specific case, and AABB basically means axis aligned bounding box. It's fancy name for the simplest collisions case. The simpler collision is, the more fancy naming it uses. So AABB, basically when you have axis aligned boxes, like boxes but not rotated, just simple rectangles, like in raylib. And you want to collide this. Collide basically means that you want to detect the event of the collision, the effect itself of the collision, and also you want to understand the strength of penetration of one rectangle into another rectangle in order to separate them. And it basically it's basically the collision detection and collision resolution stages. Let me yank some useful function from this project that I showed in the beginning. I just don't want to implement AABB collision from scratch. I already did this, and this specific tutorial is not about collisions but about the platforms, and I don't want to waste a lot of time on the collisions. And it's very simple. Let me find get AABB MTV. That's all I need. That's actually all I need. The simple function. Maybe not. Maybe for now that's all I need. Player, camera. Let me put it here. Yeah, and this was C++ fabs f. And basically this function returns MTV vector, minimum translation vector, which you need to apply to the first rectangle in order to separate these two rectangles. That's it. And now let me iterate. When I'm updating, let's say when I am updating the player, I want to update player position after all the manipulations, after the keyboard inputs. I update the position. After the velocity, I update the position. Then I aggregate this position into the player position by incrementing it this. And finally, let me check that the player doesn't collide, or if it does collide with some obstacle, we need to resolve this collision right away. So basically, collisions. Let me iterate n what n. Yeah. I need obstacles above the player, maybe like so. N obstacles plus I rectangle obstacle is equal to obstacles I obstacle rect rectangle player rect is equal to get player rect. I told that this is a useful function, player rect. We will use player rect in collisions, in drawing, and it's very useful. Get player rect. Let me pass player here. What? Yeah, player. Like so. Player rect. And now vector to MTV. MTV is what? Get AABB MTV. First rectangle is the rectangle that we want to move when we're resolving the collision. When we have an obstacle and the player, we want to move the player. We don't want to move the obstacle. Obstacle is static one. So the dynamic one is player rect. And here's obstacle rect. Well, basically it's it's not a big deal. You can of course you can swap this like so and apply the inverse MTV to the player rectangle. It will be the same. So I obtain MTV, and let me just simply say that that player position is equal to vector 2 at player position MTV. Opa. What the? Well, it's better than nothing. Yeah, of course. What just happened? Yeah, and I can reset by R button. As you can see, I click R and the game is just instantly reset. Yeah. Now, if I collide with some obstacle, for example, if I collide with some obstacle from above, I collide with the top plane of the obstacle, I actually want to discard all my current velocity. Not discard, but I want to multiply it by 0. Let's say multiply it by 0, the current velocity, because it's obvious. Yes, because if I hit some obstacle from above, I simply don't have any velocity anymore, any vertical velocity. So let me say that if I want to say that if mtv.y let me think, if absolute value of the separation vector by y component is greater than some small number epsilon, I basically say that player velocity dot y is equal to 0. And now the player won't be aggregating the velocity, and now velocity is 0. And player is not accumulating the velocity is not incrementing indefinitely, and at some point velocity is so large that the position step is enough to tunnel through the ground. And we want to get rid of this effect, and that's why I'm zeroing the velocity if the player is hitting the ground from the top. Let me, okay, it's fine. Let me add maybe some few side obstacles, vertical obstacles. Spawn obstacle x minus 20 y 20 width, let's say 5, and height let's say 10. Wrong side. Y is equal to 10. Yeah. And the horizontal collision should also work. Yeah. As you can see, I'm pressing the button and the player doesn't move here. Okay, it's good. Maybe a little bit higher. No, a little bit lower. 15, please. And maybe width 2.5. Okay. Now let's implement jumping. We definitely need jumping for our platformer game, AAA platformer game. We need jumping. We definitely need jumping. Let's implement jumping. Update player. Yes, keyboard inputs. It was just immediate step. Let me even say that this is very important stuff. Keyboard inputs. Immediate position change. Jumping. Moving. Velocity change. Because jumping basically provides some kind of impulse to the player, and impulse is just a measurement of changing the velocity. Impulse is just velocity change, delta velocity. Well, normalized by mass, but we don't have mass in this application. So let's say if is key pressed key space, or let's say W, if W I want to apply some impulse, like player velocity y, and we have y, negative y upwards, so we need to decrease y by player jump impulse. Do I need to multiply it by dt. No, I don't, because impulse, if we check physics, yeah, and as you can see, impulse, no, impulse, yeah, but maybe it is impulse. What is F? F is force. F is force. I don't see. Yeah, impulse is Newton times second. And the dimensionally equivalent unit of momentum is the kilogram meter per second. So basically this is impulse, kilogram by meter per second, and meter per second is just velocity, and we don't have kilograms in our game. Let's say that the mass of the player is 1. So basically it means that impulse is meters per second. And if I want to add or subtract from meters per second, velocity is meters per second, I need also meters per second on the other side. So we don't need to multiply or divide by dt, nothing like so. We just decrease by impulse. And we need to define this impulse now. Player float jump impulse. And also I kind of prefer to name this stuff like in real physics, using real physics units, because if you call this jump, I don't know, jump, I saw a lot of different options, but for example, jump strength is not correct, because it's not a strength, it's impulse. So if you call this impulse, it's definitely clear that this jump impulse is basically velocity change, and you can apply this velocity change by multiplying by mass. So if we have some mass, we just multiply impulse by mass and apply it to velocity change. But we don't have mass, so jump impulse. And let me jump impulse is equal to I don't know, let's say 10. Jump impulse. If key pressed, I apply this one, and that's it. And our engine, so-called engine, will resolve this velocity change later when we apply player velocity to the actual position. Jumping. Let's check. Okay, it works just perfectly, just fine, but I want to maybe increase, maybe not 10, maybe 50. It's too much, 20. I need to jump this platform. 30. Yeah. For some reason, as you can see, quite an interesting behavior when I am touching the wall, the vertical wall, and jumping. It's okay, but if I'm pressing the left button and moving left, I basically appear right on the... I don't know how to explain this, but you definitely see the problem here. And why is it happening? Because I'm zeroing maybe I should zero this. I'm zeroing the y velocity if MTV vector is greater than epsilon, and I'm zeroing maybe I should say if MTV is less than minus epsilon. Yeah. No. If MTVy is less than minus epsilon, yeah, of course. Y is flipped in raylib. If MTV is greater than epsilon, it means MTV is positive, and it means that I want to... No, it's not correct, actually. Let me think. So if I approaching the obstacle from below, and this MTV... Let me increase player speed for now. Update player. Load game. Speed 15. Yeah. Kind of. Yeah. By the way. Well, first of all, we can jump indefinitely. We need to track the fact that the player is on the ground. But maybe it's okay. No, it's not okay. It's a shitty story. We want to track that the player is on the ground. How can we track this? Well, let me... how can we track this? Player bool is grounded. So it's basically a classical approach to handle the fact that some entity, player or whatnot is basically grounded. Is grounded. And if player has if mtv.y if it's pointing upwards and upwards is negative y, so basically if y is less than 0, it means that the player is touching the ground. Touching the ground. Player grounded is equal to true. But otherwise, player is grounded is equal to false. Like so. I just thinking if this enough for detection of the grounded. Maybe it is, but maybe it's not. Anyway, is key pressed. If W is pressed and player is grounded, we can jump. Only then we can jump. Let's check. I cannot jump. I cannot jump. Why? Because player is not grounded, obviously. Why? MTV, why? I don't know. Let me print f mtv.y 0. Yeah, now we have a little bit of MTV. Yeah, maybe. Yeah. No. Yeah, of course. Well, yeah, since we have since we have not one obstacle, actually we have many obstacles, we can't just assign player is grounded by checking the MTV, because some of the obstacles may have the MTVY is less than, or maybe no. Fuck, I don't know. Maybe I should put or equal here. Maybe not or. No. Yeah. Maybe I should accumulate MTV like so. I want to iterate over all the obstacles, and I don't want immediately update player velocity, position, blah blah blah. I just first of all I just want to accumulate the MTV. MTV is equal to vector2 at MTV like so, and only after that I want to apply this to player position. I want to check the MTV Y component in order to zero the velocity, and I want to check that the player is grounded or not. Yeah, and now as you can see I cannot jump twice in the air, and this is great. Okay, so how can I fix this problem with this immediate stepping on the obstacle? I just don't like this. Let me check why the velocity in Y component is 0. Let me print mtv.y here. What was it? This one? Yeah, it was basically large negative value. It was large negative value. Large negative value. But why? Yeah, it was some negative value. I know why. I know why. No, maybe I don't. Okay, let's just move further. It's not a big deal. We will fix it later. I just need to apply this MTV resolution in the right order, and it's not a big deal. It's not a big deal. Let's implement platforms after a little bit of a smoke. So where did I finish? So we implemented this this simplistic behavior. We can jump, we can collide with obstacles, and we can fall. The gravity acceleration is acting on the player, but we have this strange inconsistent behavior. Well, maybe it's consistent, but it's strange. When the player is it basically appearing on the platform right away. When if I'm pressing the left button, I'm just kinda sliding into this plane, and also this strange behavior when I can jump from the wall. I just don't like this. I just don't like this, and I need to fix this stuff. Well, first of all, as I told, maybe maybe my computing of MTV is not correct in general, because I don't want to sum up all the MTV vectors from all the platforms. It's just not correct. I want to obtain MTV for this specific platform, and I want to track some kind of like leftmost X value and rightmost X value, upmost Y value, and the bottom Y value. So let's say MTV min X is equal to f min f, MTV min X, and MTV X, MTV max X, like so. And I need the same for Y. Substitute X with Y. Max Y, MTV max Y. Yeah, and I need to define this these variables. Float, and let's say minimum. Yes, I can put 0 here. If I want to find maximum, I also actually I can put zeros everywhere. Yes, and up, and only after that, when I not clamped, but restricted MTV by the maximum and minimum values appeared during the iteration on the obstacles. And now I can just say that vector2 MTV is equal to vector2 0, for instance. Or actually, yeah, 0 maybe. And I can say if absolute value of the, yeah, now I just need to clamp this stuff. Not clamp, but select maximum values maximum absolute values, like if absolute value of the MTV min x is greater than absolute value of the absolute, or yes, MTV max x. You know what? Let's say that MTV is MTV min x, MTV max x, and if MTV max x is greater than MTV min x by the absolute value, I just say that MTV x is equal to MTV max x, and the same stuff for y component. Y. Okay, and only after that I can apply this MTV to the player. Let me just also I need to resolve this grounded stuff. Let me say that if player is touching the ground, so if basically MTVY is less than 0, and not and, let's say less than 0, it means that player is touching ground from the from above. So player is touching the top plane of the obstacle, and I can say that in this case player velocity is 0, vector to 0, and how did I call this? Player is grounded is true. And from the beginning I just have or maybe not from the beginning, just else player is grounded, false, like so. Let me run this stuff. Okay. MTV. Let me quickly print this. MTVY. Yeah. Player position. I just don't understand. MTVY less than 0. It was Y. It was positive. MTV min x, MTV max x. Yeah, of course. I'm an idiot. Why? MTV max y min y. It's a stupid mistake somewhere. MTV min x, MTV max x. Min y. min y. Yes, it's left boundary for x and top boundary for y. Yeah, max y, min y. Yes, like so. Okay, can I jump? Yes, I can. Can I? Yes, and now I am sliding. Okay, how can I fix this sliding problem? Let me just check that I am grounded and velocity is 0. Only if MTV is less than 0, but also player velocity is greater than epsilon. But player velocity on the y component. It basically means that maybe greater than 0 is enough in this case. It basically means that player velocity is pointing downwards. So first of all, the player is touching the ground, MTV is negative, pointing upwards, but the player itself is moving downwards, so the velocity is negative. And only in this case I can say that the player is grounded and velocity is 0, because if MTV y is less than 0, so player is touching ground from above, but player velocity is less than 0, so if player is moving upwards, it basically means that it's just occasional collision, and I don't want to resolve it. At least I don't want to. I want to resolve it, and I am resolving it, but I don't want to say that player is grounded or the velocity is 0, because the player is just don't touching the ground from above while falling down, and it means that maybe we also do have another condition, like if MTV y is greater than 0, so it basically means if the player is moving upwards, but the situation is the same, but in reverse fashion, if the player velocity y is less than less than 0, this means that player is touching not ground, but in this case ceiling, and yeah, and I just want to say that velocity is 0, but maybe by only y component. Yeah, and is grounded is we don't set is grounded here, because here the player is just touching ceiling, and when the player touched the ceiling, I don't want to continue accumulate velocity, not accumulate, but I don't want to continue treat the velocity like not 0 value, because in this case player will freeze for several moments at the bottom, at the ceiling. So basically the player will stick to the ceiling for few moments. Give me a second. MTV, we don't need to print MTV here, and after that I can apply. No, I already applied MTV to the position. I already applied it, and now I just setting flags and velocities. Collisions. Okay, let me oh my god, 73. Velocity, position step, keyboard inputs, gravity, collisions. Yeah. Let me run and check this stuff. I can jump. Yes, I can jump. By the way, am I recording? Yes, 15 minutes. I can jump, and finally, yeah. finally. Yeah, and as you can see, we continue moving when we touching this floor. We don't stick to the floor, do we? No, we do stick. But why? I understand. It's okay. It's all right. It's fine. I'm just stick to the little pixel of the bottom platform, and this is okay. It's okay. It's all right. It's all right. Yeah. To this, I'm just sticking to this platform, to this horizontal platform, but from this side. And I even can't reproduce it every time. Yeah. Okay, it's all right. It's not a huge deal. Okay, now let me implement platforms. This one we fixed. Yes, now we are ready to implement platforms. Let's maybe create a platform somewhere here. Here. Or maybe vertical one. It doesn't matter. Horizontal one is better. For debugging purposes. But we will implement both options. Let me make a small break to smoke a cigarette and I'll continue. Okay, let me continue. Where is my coffee? Am I recording? So, let me implement a platform. Should we create separate structure for the platform? Player. Maybe the time has come to implement structure for obstacles itself, because now we are using rectangles. Let me quickly implement obstacle. I will use the same structure for obstacles, for static obstacles like ground, and for moving obstacles like platforms. So type def struct obstacle. What do we have? We have rectangle, rect. We have let's say for now just rectangle. Number of obstacles, obstacle, spawn obstacle, 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 rect is equal to rect. Here obstacle, obstacle, is equal to this one. Obstacle rect. What else? Obstacle. Obstacle, let's say obstacle rect is equal to this one. Alright, let me check. And let me create platform specific members. Let's say, well, maybe it's even not a platform specific. No, it's platform specific. It's platform specific. So maybe I should say, well, let's just say that vector2 velocity, and if the length of the velocity vector is less than some small epsilon number, I just say that this obstacle just doesn't move, it's not a platform. So I don't need a separate kind of flag is platform, because I can simply compute the effect of the platformness or not platformness in the runtime. Velocity, and let's say update player, update obstacles, update reset, load game, drop player. Well, maybe here, yeah. Void, well, not here. Update obstacles, in obstacles, draw obstacles, spawn, void update obstacles, void, and let's iterate for int I is equal to 0, I less than n obstacles, plus I, obstacle bool is platform, vector2 length obstacle is greater than 0, or maybe even epsilon. Well, 0 is enough. Obstacle velocity, if not is platform, I just continue, because it's nothing to update for static obstacles. Okay, let's just update get frame time in the same manner as we updated the player. So we basically say that vector2 position step is equal to vector2 well, maybe I should separate not velocity but direction and speed, because I don't want the user of the obstacle structure to think about normalization of the velocity. For example, if I want the platform to move towards some kind of diagonal direction, what kind of velocity should I assign to the platform? What kind of velocity? Imagine that we have velocity here, and I want to move diagonally with some angle to the right and to the up. So for instance, positive x and some negative y, but which y, -1 or -0.5, I don't know. So I just asking the user of the structure, this obstacle structure, to provide just a direction. It could be 1.1, it could be like so, and I just will normalize, I will just normalize this direction and stretch it with this kind of speed. So user of this structure just need to think about direction and speed. It's a little bit more convenient than providing the velocity itself. Direction, platform, yeah, and now I just speed, and maybe even I don't need this stuff. Skip, actually don't update non-platform obstacles. Yeah, like so. And position step is basically vector2 scale, obstacle direction, and scale obstacle speed. Yeah, and also it's useful because we can change speed and direction independently. Imagine that you have some kind of velocity of the platform, and you want, for example, to change only the absolute value, the speed of the platform. How can you change this if you have only velocity? You need to compute the hypotenuse and whatnot, and it's just not convenient. But if you have speed, you basically saying that, for example, like so, yeah, and you're done. You don't need this on any frame, but it's just an example of increasing the speed of the platform. Position step, and let me just apply this position step to the platform position, like obstacle obstacle rectangle x plus equal position step x obstacle rectangle y position step y. That's it. I believe that's it. For now we updated all the obstacles. Let me now create new, first of all let me check everything is working. Yes. Am I recording? Yes. Let me now check check what? Not check, create load game obstacles. Do I need this? No, I don't need this. Yeah, I'm zeroing it now. Spawn obstacle rectangle x, for example, is equal, I don't know, let's say -10. Y is equal to maybe, let's say 10. Width is equal to, let's say 5. Height is equal to 2.5, like so. Yeah, maybe, but a little bit higher, like maybe 8, and width, let's say 10. Okay, can we jump here? Yes, we can. Now let's make this stuff move, maybe a little bit to the right. Yeah, maybe, by the way, maybe it's fine. maybe it's maybe 10, even 10. Yeah, jump here and then I can jump on the platform. Yeah, and let's make it moving. Let's make it moving like direction, not rectangle. This is just a rectangle. No. Spawn obstacle. Float. Not float. Vector 2 direction. Float speed. Let's say spawn static obstacle, and let's say spawn platform obstacle rect. I need vector 2 direction and I need float speed. Obstacle direction is equal direction. Obstacle speed is equal to speed. Spawn static obstacle, and let me just return vector 2 direction is equal to vector 2 0 and float speed is equal to 0. Return spawn platform obstacle, rectangle is rect, direction is direction, and speed is speed. And let me rename. It's not platform, it's more like obstacle, like generic obstacle. And this is static one when this stuff is equal to 0. Okay. Spawn static, and this one is spawn obstacle, and I need to pass the direction and speed. Direction will be let's say x is equal to -1. Well, how can I make the platform moving in both sides? Maybe I need yeah. Because now let me show you x -1 and y is equal to 0, for example. Yes, and speed is equal to is just absolute value. Yes, speed is equal to, I don't know, 3, for example. Yeah, not this. This is vector 2. Yeah, watch. Okay, it was too fast because I forgot to multiply by dt. Here dt times this one. Yeah, and as you can see, it's moving, but the problem is that it's moving indefinitely. maybe we need to define something like platform, not the direction, but maybe speed and starting point, and well, basically some kind of route for the platform. But in our simple case, the route will contain only 2 points, starting point and end point. So let me say start vector 2 end, like so. Spawn obstacle, vector to direction, start, vector to end, start, end, and speed. Yes. And when we spawning obstacle, spawn obstacle, start vector to start, for example, rect x, rect y, vector to, I don't need this here, and end is just start. And I can spawn this rect start end and speed is equal to 0. Well, formally I can just put any values here, starting that, but maybe not. Anyway, the most important part is that speed is 0 for static obstacle. Okay, direction, yes, and here when we are updating obstacle, we want kinda track some boolean value, bool is moving to end, for instance, is moving to end. Yeah, and is moving to end is true by default. Let's say is moving to start, because is moving to start should be false by default, because we're moving to the end from the beginning. And it's just more convenient because we're setting all the bits of these structures to 0, and is moving to start will be 0 by default. It will be 0 by default. Let's check if this is not obstacle. We just continue. 0 speed. If obstacle is moving to start, we just take the direction, vector to direction is equal to vector to difference, not difference, but subtract from if we are not moving to start, I just say that direction is the difference. Let me say, it means that I'm moving to end if I'm not moving to start. So I'm saying that obstacle end minus obstacle start. When you're subtracting one vector from another vector, you're moving towards the vector which you are subtracting from. In our case, we're subtracting from end. It means that we are moving this direction pointing towards the end. But it's not a direction now. Direction will be normalized. Vector to normalize direction. This is my direction, and I can say that if obstacle is moving to start, I can just flip the direction. Vector to scale. Do I have flip in not reflect? Vector to negate. Direction, yes. So basically we take the direction of the platform, but if we are moving towards the start, we just flip this direction. Direction and position step will be, but also I need to decide if I want to you know what, maybe because I just thinking that rectangle has some kind of x and y coordinate, yes, so rectangle has a position, but also I have start and end, two positions. So obstacle in current situation has three positions. It's rectangle position, it's start position and end position, and it just doesn't make any sense. Let me say that obstacle has just size, vector 2 size, and position, vector 2 position, size and position, position and size. Well, no, it's okay, it's alright. So I have a direction, and let me just check if obstacle is moving to start, if I'm moving to start. Well, well, first of all, let me check that this start and speed and rectangle, start and speed, rectangle. Let's say start, for example. Start, for example. Start. Well, ideally I want to put start at the beginning of the platform. So this is start, this is end, or this is x, this is y, and end will be, for example, minus 20, like so. And now I'm moving towards the end, but now platform will not stop. Yes, as you can see, I need to check the fact that I already reached the end position. Okay, position. Let me check that the current position I want to update it at the very end, so I can check, I can resolve this target reaching logic in the beginning. So I basically say that vector 2 position is equal to obstacle rect x, obstacle rect y. target, let's say target vector to target is equal to obstacle if moving to star, then starting point will be not starting point, target start, otherwise obstacle and distance. Now float distance to target vector to distance from position to target. If distance is less than epsilon, I just flip obstacle is moving to start. I just need to flip this value. To flip binary value, to flip boolean value, or actually to flip, I should say bit value, you can use XOR in place, like so, XOR with 1. Let me demonstrate this. Let's say I have some flag is equal to true, for example, flag true, and if I XOR this flag with 1, I effectively just flipping the value. So flag is 0 now. If I flip one more time, flag is 1, I flip, flag is 0, flip, you get the idea. So I basically just flip the value, that's it. Not flip, let's say reverse platform movement if it reached the target. Get platform direction immediate position change. All right, that's it. Let me check. Let me also increase speed of the platform. Load game, maybe 6. No. Let me draw obstacles. Let me draw start and end point also. For now, draw circle V. Center is obstacle start, radius for instance 0.1, red, and end also red. Yeah, I have these 2 points. I have also this too, but for some reason it didn't reverse. Position if distance, position target, rect X, rect Y is moving to start. And distance position target. Let me print f distance. Yeah, it decreasing. Ah, yeah. It's very interesting tunneling effect, because it could be the situation when the position step is greater than this small epsilon, and I need you know what let me take the platform direction first. Let me take the platform direction, and let me take vector 2 to target direction. To target direction is equal to vector 2 subtract from target. I want to subtract position, and this is to target direction. And how can we check that the platform direction is corresponding to the target direction? Well, in linear algebra, it's you have dot product, vector 2 dot product. I don't want to explain in large details how is it working, but basically dot product is just multiplication of two vectors element wise. So if you have two vector 2 objects, you multiply x by x, y by y, and then you just summing up the results. And if this dot product is positive, it means that vectors pointing to not to the same direction, but at least not in the opposite ones. So maybe they pointing with wide angle, maybe with narrow angle, but in general it means that they are pointing towards some global horizon. So let me check. Direction with to target direction bool is moving to target is equal to dot product is greater than, what is the sound, is moving to target. And now if is not moving to target, now I can flip this stuff. I don't like this. I don't like this. Is moving to is to target. Okay. I just like to keep stuff short. So if it's not fitting the line, I'm just trying to maybe simplify the naming of the variables or functions. Anyway, let me check. Yeah, but here is the problem, but maybe it's okay for now. We are working with top left corner of the obstacle. Yeah, maybe it's okay. Maybe it's okay. By the way, maybe I won't even check this stuff after I apply step, because it's kind of collision resolution, but for platforms. Yeah, and we basically don't collide with obstacles, but we collide with target points. It looks like the collision resolution, and we usually want to resolve collisions after we change the position, like in like in player update function, when we first change the player position and only after that resolve the collision. I should even leave a small comment, reverse platform movement if it reaches the target, e.g. Maybe here. Well, it's okay, it's alright, it's understandable. Oh, it's time to smoke, maybe a little bit later. Reverse platform, yes. Yeah, and now I want to implement the logic that I'm actually not falling from the platform, because now, sorry, I wanted to make one more thing. When I updated player position, after that I'm checking that I'm not overshoot the target, and if I'm overshoot the target, I need to clamp the obstacle position, because now I don't know if you can see or not, but when the platform touches the left point, sometimes it touches, but maybe it's not, I don't know. I think it sometimes overshoot or undershoot, I don't know. Let me just clamp the obstacle position. If not pointing to target, let me check if obstacle is moving to start. I just say that obstacle rect x is equal to obstacle obstacle start x, obstacle rect y is equal to obstacle end x, not end, what am I doing, start y, else obstacle rect is equal to end. So I basically clamping the obstacle position, and then I change the flag. Let me even say vector2 clamped position is equal to this obstacle start, and this is obstacle end. And now clamped position xy, yeah, like so. Else clamped position. What do you want? I just don't understand. Sorry. Brain fart. It's a brain fart. Oh, fuck this shit. Okay. Clamping, reversing. Let's check. Yeah, but nothing has changed actually. But now it's correct. Now I'm sure that this is correct. Okay. How can now I how can I implement this sticking to the platform now? How can I implement this now? Let's say, so basically it could be several approaches, several strategies. I prefer to use some kind of array which is attached to obstacle, and this array is storing all the entities which are basically standing on this platform. But since we have only the player and we don't have any other entities, maybe I can do this without arrays. Well, let's a little bit, I don't like overgeneralization, but in this case I think it's a good exercise to implement multiple entities. At least the possibility of having multiple entities on the platform and general in the world. So let's say obstacle platform stuff. Let's say okay, let me smoke a little bit and I will continue. Yes. So let's continue. Platform. Let's say that the platform has some kind of array of entities on this platform. But what is an entity in this case? Actually, I only need entities positions. So how can I call this? Let's say vector2 I don't know, let's say entities. Let me think a little bit. Struct player. Let's maybe say that it's not the player, but just let's say that it's just a creature, and now, well, do I really want to refactor it to be creature? Player, maybe not now. Well, you know what, let's maybe I changed my mind. I don't want to complicate stuff. Let me just say that platform bool is player attached. By default it's false by default, but when I am updating obstacles, I just check that that not here, no, update player, yes, I'm iterating over all obstacles, and I'm just checking if mtv dot y is less than 0, if mtv.y is less than 0, it means that I'm touching this specific obstacle, and also if let me say obstacle is equal to obstacles. I'm sorry for this noise, they always constructing something in the nearby flat. Obstacle, not rect, obstacle rect bool is platform. Vector 2 no, yeah, we do have speed. If speed is less than 0, yes, I just say that obstacle is player attached is equal to true. Otherwise I say that else is equal to false, and maybe I can do it like so. Attach player to the platform. If needed, player is attached. Okay, and now when I am updating the obstacle, update obstacles, I can just moving if obstacle is player attached. I just say that player what? I just say that, well, I need global. Well, as I remember, in the first session I said that I prefer to pass player by pointer, but now, as you can see, it's not particularly convenient. I can wrap all the logic in some kind of global structure and name it like a game, for example, and get access to the player and whatnot. But we don't need the global structure. We are already in C module, and C module itself acts like a global structure, global namespace. So maybe I was wrong about the passing player by pointer. Let me change my mind. Void and player, I want to change player arrow, I want to change player dot. Yeah. And player where is the player, by the way? Player. Yeah. Player is here, like so, like so. Like so. Get player rect, like so. Okay. Get player rect update player. It's alright, it's alright. And now when I am updating this stuff, I can just say player. Fuck. I need player above. I need player above the obstacle, yes. No. Where should I put it? Do I need to forward declare it? I just don't like this forward declaration stuff. Update obstacles. Yeah, I need to keep it here. Okay, not a big deal, not a big deal. Let me take this player structure and just put it here. It's not a big deal. Yes, and also this, like so. And now player, if player is attached, I just say that player position is equal to player position, add vector to add player position and immediate obstacle step, position step. So basically we can change, for example, player velocity accordingly to the platform movement, but I prefer to change the player position directly with the position step, because it's kinda not physical. But you can distinguish these two cases, like if you have some physical behavior, for example, force acts on some object, or object is moving by some internal force, for example, like engine of the car and whatnot. We want to keep this physical physics related stuff closer to the velocity or to the force variables and so on. But if we have some kind of non-physical behavior, like immediate step because of the platform movement, it's not physical behavior. Well, it's physical behavior, but in our case we just cannot simulate the friction force, we cannot simulate the inertia and whatnot. So I basically treat it like non-physical behavior and I update position immediately, like so. But how can I check that player is not attached? And I already checked it here. Yes, let's just test. Let's just test. Okay. I can jump. Yeah, perfect. It's perfect. And as you can see, I just sticking to the platform and no problems. I can jump. I don't stick to the bottom side of the platform because I'm sticking to the platform only when MTV is negative is pointing towards the up direction, towards the ceiling. Yeah. It works fine. Okay. Let me remove these red dots. Okay, what else can we do here? Let's maybe create more interesting level. Let's maybe create several different platforms on different levels. And for example, target of the game is to reach the up point. So let's say spawn obstacles. Let's say this is ground and this is platforms, and let's say less than 10 plus I. How many obstacles can I spawn? Let's say it's not a big deal. 64. 64 is just the maximum capacity of the array. I will spawn in my case 10 obstacles, and let's say that each obstacle has some kind of elevation. Float y is equal to, we will start with 0 or with 8 plus I multiplied by I don't know, let's say 8. This is y. Yeah, but I need to inverse this. Yeah. Okay. Maybe I need to set different starting points for them. Update obstacles, and also, you know what, I want to maybe update player. I want, because I don't know if you can see this, but player actually, it's a little bit overshooting the horizontal collision. How can I yeah, I don't know if you can see this, but it's a little bit of a pixel which overshoots. Anyway, I want just to resolve player collisions. I want to factor out this stuff. Update player collisions, and I want to update them after I apply the immediate step. Void update player collisions, void, like so. Update player, and let's update player, update obstacles. Yes, like so. Now I shouldn't overshoot. Yeah, now it looks fine. So the basically the logic is that you want to resolve your collisions at the very end of your updating of your update cycle. Otherwise you will draw unresolved collisions, because we will draw stuff after the update function, as you can see. And if you update such that for example, you update this stuff at the end, update obstacles, and if you remember, we apply immediate step here. It could be the case that we applied immediate step and then we draw stuff, and it may look just incorrect. We need to apply immediate steps, all immediate steps, and then we need to resolve collisions, and only then we need to draw stuff. So the order usually is the following. Okay. Let me return to the platform spawning problem. I want to spawn them at the different places, the different platforms. I want to spawn them in the different places. How can I pick spawn place? Okay, let's say float x is equal to I need to take random value in between. Does raylib have something with get random value from minimum and maximum? But this is integer, yes? Yeah, this is integer. This is integer. Okay, let me take random value between 0 and include. I always int types, maybe. I don't remember. I need just max int, no, int 32 max. Yes, and no, not from here, and I just divide on float int 32 max, and let's say that this is some kind of a ratio, or p, I prefer p, like probability, like value from 0 to 1. It's just a value from 0 to 1. And now I can pick some point from start x x min is equal to 10, x max is equal to I don't know. Yeah, x max is x min is equal to minus 20, x max is equal to 10. Yeah, starting point is x min. Yes, x min, x max. Let me just check that everything is working here. Okay. Am I recording? Yes. X min, x max, and x float x is just some random value between x min. So I basically take the range x max minus x min. This is my range of the movement. I multiply it by ratio. Yes, for example, ratio is 0.3. So I take this range, I multiply it by 0.3, and I obtain 30% of this range. And I just add it to the left point, minimum point. Yeah, and this is my starting position. X. Let's check. Yeah. And now, and maybe I should pick random speed. Let me say, let me create several utilities, few utils. Float rand f, for instance, void return the stuff, returns value returns float value from 0 to 1. Returns float normal value, not normal, uniform. We call this uniform. So basically the probability of any number in this range, these probabilities are equal. It's uniform distribution. And let's say float randf min max. Give me a second. Float min, float max. Float p is equal randf. Return. I want to add minimum plus p times range. Range is maximum minus minimum. Yeah. Okay. Returns float uniform value from min to max. Okay, and let's say p is equal to, no, x is equal to randf min max. Minimum is x min, maximum is x max. And I don't need this. And let's say float speed is equal to randf min max, minimum speed, let's say 6 or maybe 5, and maximum speed, let's say maybe 9, and this is speed. Yeah, and as you can see, they now have different speed values. Okay, what else can you do with platforms? Well, first let me just implement camera following. Let's say update, reset, update player, and let me just move the camera only after I resolve all collisions, only after I update all immediate player position values, blah blah blah, and only after that I want to update camera. Update camera. Camera. Maybe not here. Not game. Yes, maybe here. Update camera. Let's say that simply camera target is equal to player target for now. Player what? Player position. Player position. Maybe it's enough. Yeah, I don't like that player always in the middle. I like to add some kind of inertia to the camera. Maybe I should implement this. Let's say camera target vector 2 target is equal player position. This is target, camera target, but the actual distance from the camera center and to the target let me think. Let's just try to set Player position dist to player. No, let's say target. It's understandable that it's about the player float. Distance to player is equal to vector to distance from target to camera position. Camera position is camera target. Its distance and let me say that step size is depending on the distance between player and camera. The larger the distance is, the faster the camera is moving. So I basically say that step is equal to for instance 0.9 times distance. Now I check that now I just can apply this stuff. I need to take the direction. Direction is equal to vector 2 subtract from target camera position, camera target. This is my direction, but normalized. And step vector 2 step is equal to we usually call this vector 2 position step is equal to vector 2 scale. I want to scale the direction by the 0.9 times distance, for example. Position step. The camera target is equal to vector 2 add camera target position step. Let's check. Maybe it's too strong. Position step. Maybe like so. Yeah. Yeah, maybe like so. I need to draw some kind of background because now it's just you just can't stick your attention to some static point on the screen. It's difficult to follow this stuff. Let me add some kind of static background. How can we do this? I just want something simple. Maybe let's implement some grid, maybe lines, maybe grid, I don't know. Let's say draw obstacles, and at the very end, maybe at the very beginning, because I want the background to be in the background, not in the front of other stuff. Draw, let's say draw background. By the way, I don't need player this here, I mean, yeah. Draw background. Okay. Draw player void draw background void Wait. And let's say that we want to draw some background. Let's take player position. Well, let's maybe even for float y is equal to, for instance, minus 100, y is until while y is greater than 100 positive, plus y plus equal to 1. This is y. And now let's draw line v, start position. Vector 2 start is equal to x, for instance, minus 1000, and y is y. Vector 2 end is equal to, for example, 1000, y. This is start, this is end, and color, let's say ray white. I don't know, ray white. Let me check. What? X minus 100. Sorry, until x is less than 100. Sorry for this epilepsy attack. Maybe 5. Yeah, but you know what, I need vertical lines because because I can visually understand the vertical movement by the platform change, but I can't visually understand the, yeah, maybe I should implement. Well, you know what? Let me just maybe. I'm just trying to. I'm just playing around. It's okay. It's all right. I'm just trying to polish this game a little bit more before we finish up. Ground. Let me just spawn x is equal to minus like so, and height like so. No? No, sorry. Not x, but y. Y is equal to let me minus 100 and height is 100 more. Yeah. And now maybe I need a small platform. Spawn obstacle x is equal to minus 17.5, y is equal to minus 15. I need to lower it. X is equal to 0. not 0 but minus 15. No, y is equal to, I need to increase the stuff, so basically 10. And height is equal to 5. Yes, beautiful, beautiful. Beautiful. Maybe I want to spawn the right side of the field. This is ground. This is left wall. This is left wall stair, left stair, left wall, right wall is equal to x. X will be what? 20? Almost 15. No. Yeah. Yeah. And also maybe I need to clamp a little bit starting and end points of the platforms. X is equal to x min, let's say minus 15, and x max, yeah, to the right, and this to the left. Yeah, like so. So yeah, that's it. I think that's it. That's enough to show the basic logic of implementing platforms, collisions with platforms, and basic AABB collisions and whatnot. And you simply can implement, for instance, let me show just last example, not last example, but the last idea you can implement here. For instance, you want to implement the damage from the falling down, like so. What you can do? You can simply, when you're updating the player, but maybe when you're updating the collision, and if let's say player velocity when we apply this to the player, yeah, we basically can check if mtv.y is less than, let me factor out this stuff, is just grounded, ball is just grounded, like so. And if player is just grounded, I can check I can check the player velocity. I can check the player velocity. Float speed, let's say, vector2 length player velocity, and as you remember, speed is just velocity but scalar value. So if you take the length, the magnitude of the velocity vector, you obtain speed. So it's just a single value, and you can check if speed. Let's just print it for now. Print f speed like so. Let's just check the speed. It was only when I grounded. Yeah. Let me, for example, ground from the first platform. As you can see, speed was 45. From the first platform. Let's say from the second, or maybe, yeah, from the second one. Whoa. Also 45. Why? 40, 90, let's say from here. 63. Let's say that if speed is greater than 50, we just hit the ground with large speed, and we can decrease player speed, player health, or we can show game over screen and whatnot. I will just for example, n hits, n I just let me player hit the ground. You can decrease player health now. And as you can see, if I now drop from high distance like so, yeah, and as you can see, we have this logging string that player hit the ground. Yeah. Oh, yeah, it's enough. I just have a lot of ideas, but I just don't want to spoil this anymore, because it's a good starting point. You can implement different systems here and whatnot, and you don't even need OP to implement this kind of logic. Okay. So I will finish now. I will commit this into some repository and attach the link to the description of the video. Yes, that's it.